Hey folks, welcome back. This is Joel, and in this video we'll talk about setting up a layer 3 data center interconnect over VXLAN. Now in the previous video we used the exact same topology, but we actually accomplished L2 DCI, right? So if I go onto my whiteboard here, if you have not checked out the previous video, do check it out. Right, so this was the topology which were used in the previous video as well. If I grab my pen here, what we really did was we actually tried establishing a L2 overlay, right? So we tried connecting all these three hosts which were in say VLAN 101, and they were able to talk to each other. Similarly, we also created overlay or L2 overlay so that all the hosts in the VLAN 102 were able to talk to each other as well, right? But if you remember, at the end of the session, we also added a bonus content where we, in addition to creating a L2 overlay, we also created a L3 overlay, right? But we did not use VXLAN for it. We used external router for that. So you see these routers over here, we use these external routers for that purpose, right? And as a result, we were able to route between these two segments as well. So that is all what we did in the previous video. Now in this video, what we will do is we want to create the routing, right, natively inside VXLAN, right? We don't want to be using this external router. Rather, we want to establish routing natively inside VXLAN, and for that, obviously, we have discussed this before. We'll be using symmetric IRB, right? So symmetric IRB or integrated routing and bridging. So that's what we are going to be doing, right? So we already have the configuration for the L2 overlay. In addition to that, we'll be adding the configuration needed to accomplish this. Perfect. Now, just to kind of prove it to you that I'm going to be cutting down these routers, right? So I'll be basically cutting down these routers. That is what we'll be doing as a step number 1. And after that, we will do our configurations. And finally, I will show you that we are able to talk between, these two hosts which are in two different segments or two different L2 VNIs, right? We'll be able to communicate between these two because our VXLAN is going to be doing the routing as well, right? We'll be doing the routing within VXLAN. Okay, great. So let's first do that. Like I said, step number 1 is basically killing these routers. So let's kill these routers, right? And let me just show you that. So let's go on to my screen here, right? Just to quickly verify, just to make sure that the configuration is as it is since the previous video. We'll just quickly verify. I'm going to go on to this particular host and I'm going to see if I can connect to the rest of the hosts, right? So this is 101, right? I'm gonna do ping 10.0.101.10, which is my own IP. I'm going to ping the endpoint in the which is behind leaf 2, which is .20, which seems to work as well. Let's try to ping .30, and that seemed to work. Perfect. Let's now ping the endpoint in the other segment, right, which is 102.10, right? So that's the IP address of what? That's actually the IP address of this particular host, right? So in a different segment itself. So I'm going to be pinging, and you see it works. If I change this from .10 to .20, that is working. Change 20 to 30, that works as well. Perfect. So we are clearly able to kind of ping between we are able to kind of ping within the same segment. That is, our L2 overlay is working, and we are also able to ping between two different segments, which is because the routing is working in the external, because of these external routers which we have put in place, right? Remember, I think there were a couple of ping drops here, but that's fine. Now it's working, right? Remember, we have also set up VRRP for our external routers. So maybe if I quickly show you that, I think maybe R3 is our, let me just reconnect this guy, right? So if I go on to my R3 and if I do show VRRP, there you go. So you can see VRRP master, right? So R3 was the VRRP master. Rest of the two guys were the backups. Great. So what I'm going to do now is I'm just going to quickly cut off the routers, right? So I'm going to go to the interface. I'm going to shut these guys down. Okay, so let's do that here as well. Interface Ethernet 0/0. I'm gonna shut this guy, and let's go on to this guy. Maybe disconnect and connect back. Cool. So I'm going to shut this guy. Right now that I've shut down all the 3 routers, what should not really work? The communication within the same segment should still work, because that is just bridging, right? That is not using the routing, which means I am right now on show IP interface brief, right? So I'm on the 101 machine. From that particular host, I should ideally be able to still ping what? .20, correct? This one still works. But what I will not be able to ping, I should not be able to ping across the other segment, which is, if I change this to 102.10, this should not work, correct? Because we have cut down the routing, right? We have shut down the external routers from our topology. There you go, it's not working. Right now, in this situation, what are we intending to do? Our goal for this video, or the game plan for this video, is to enable routing within VXLAN itself, right? So that is why the title of the video is called as L3 DCI, right? So we'll be creating, L3 overlays, right? We will create L3 overlays, and we will basically enable the IRB, right? Integrated routing and bridging, right? Using L3 VNI, so that if this guy wants to talk to this guy, right? We will make that possible, right? We'll make that possible, because right now these guys were not routing, but we will put some configuration on these leaves to enable routing, so that they'll be able to route between the segments within the same VRF, right? So that's the goal for this particular video. Now let's start with the configurations. All right, so let's start by configuring our leaf 1, right? Just to show you what is the current configuration on the leaf, that is what we can see here. Let me disconnect this guy. So I'm going to only show you the configuration on maybe one of the leaf, and then I will do the rest of the configurations in the background, and then I will quickly show you the final configurations on the device. Okay, just to show you what is already there, and this is what we have done in the previous video, right? I have not done anything else beyond it. So as you guys can see, starting with, we have the host name, right? Then we have created the 2 VLANs, which is 101, 102, and we have the EVPN configurations, as you see here, needed for the L2 VNI, creating for the L2 overlays. This is the connection to the uplinks, right, towards the WAN router. This is basically the downstream, right? This is the towards the servers, we have basically made that 1/1/4 interface as the trunk interface. We have the other interface towards the router, right, is also trunk, but now this interface will not be used, because we have shut the router, right? So this interface will no longer be used. We have a couple of loopbacks needed, and finally we have the VXLAN configuration, right? The data plane VXLAN, so source IP is this loopback, and then we have created the 2 VNIs. We have the BGP OSPF configuration, right, for the underlay, and finally the BGP, right? BGP, nothing very complicated. We are just creating, we are using iBGP, 65500 is the AS number, right? We are using source, update source with loopback 1. These are the 2 neighbors, right? Leaf 2 and leaf 3, and we are sending community, we are activating the neighbors, right, for the L2 VPN EVPN address family. Straightforward configuration. But now let's start by, what do we need first, right? Whenever we are talking about L3 VNI, we gotta create a VRF, right? So we'll create a VRF 1, right? You can give any name, I'm just using VRF 1. We'll have to put a route distinguisher. So I like to put, normally the route distinguisher is use the AS number of the BGP itself, and since this is leaf 1, we'll just say :1. The route target, you can either keep it to auto, or you can explicitly configure, right? So I'm going to be using the route target. So this is basically the route target for your IP VRFs, right? Remember, we have talked about this previously when we talked about VXLAN. Normally in VXLAN you have the MAC VRF, and that is identified by the the MAC VRF configuration is nothing but this configuration, right? Then you have the IP VRF configuration, which we are doing right now, right? And then you also have your traditional VRF, right, which is for the address family IPv4, right, unicast IPv4. All right, so I'm going to keep probably something same. I'm going to use the same route distinguisher as route target as well. Remember to put the address family EVPN. Change this export to import, right? Because whenever you create route target, you need export and imports, right? So that you can import the routes as well. Cool, that is good. Let's create the SVIs. So we need two SVIs, 101. We will have to first attach this to the VRF which we just now created. We will next put in an IP address. Remember we have used 10.0.101.1. This was the IP address which we used on the router earlier, correct? Over here, this is the router show IP interface brief. So I'm going to use the same IP, yes, 10.0.101, right? So I'm going to be using the same IP. Since we have shut down the router, we can now reuse the IP. We will not get any duplication issue, right? So I'm going to use the same IP. Since we have shut down the router, I'm going to be using that guy, right? And remember, we like to create a distributed gateway, right, for whenever we use symmetric IRB. So for that purpose, I'll be using the active gateway feature on the Aruba CX, right? We did something similar in the Cisco's world, right? In the Cisco's world, there was a command, I think called as fabric anycast gateway something, but here we have active gateway, right? Just go read about this if you're not very familiar. Active gateway is a very common feature used in the Aruba switches, right? It does very similar functionality as VRRP, but it provides you the whole active anycast behavior. Okay, anyway, so anycast we'll have to put in MAC address first, right? So I'm gonna stick myself to maybe 12.0.0, then probably 0.1.0. Okay, I can reuse this MAC because you know it just has to be unique within the VLAN, right? So I can reuse this same MAC for the other active gateways as well, should be fine. I will have to put in an active gateway IP which is 10.0.101.253. So this guy is already configured as my default route on my end host. I'm gonna use the same thing. So if you look at here, show run pipe include route, right? So you can see this is the default gateway used on my clients. I'm gonna be using the same guy as my active gateway IP, right? No shut. Similarly, let's do the other guy, right? Interface VLAN 102. Let's first attach the VRF, very similar to this one. Let's put the IP address. It's going to be again very similar. Just change this to 102.1. Active gateway IP MAC is going to be same. Active gateway IP will change from 101 to 102. Cool, no shut. So we are done with all of that. Next, let's do what do we have in terms of the VXLAN configuration, right? Show run interface VXLAN. This is what we have. So in addition to this, we have to introduce the L3 VNI now. So I'm gonna get inside the. Let me just clear the screen. Right. So I'm gonna get inside the configuration, and we will have to introduce the L3 VNI. So I'm gonna use L3 VNI called 1000. Can be anything, but in my case I'm just sticking to 1000. You will have to enable routing for it. Okay, my bad. So before doing that, we will have to you put the VNI, and before enabling routing we'll have to put a VRF. So I'm gonna say VRF1, and then I will enable routing, right? That works. Next, what do we need to do? Because we are doing symmetric IRB, we also need the type. What are the different type of routes needed, right? So you have type 2 routes, which is just MAC only, and then you'll also have MAC plus IP, right? Those are your type 2 routes, but you also need type 5 routes. To enable type 5 routes, we have discussed this previously in our symmetric IRB video, but let's go back to the BGP configuration. So if I do show run BGP, so this is what we have. We'll get inside router BGP. We just need to go inside the VRF1, enable address family IPv4 unicast. Okay, then we will redistribute connected. That way, all the VLAN 101 and 102 subnets will then be sent as type 5 routes to the EVPN peers, right, to the other BGP peers. Cool. So we are exiting the address family now. I think that should be fine. What is the only other configuration needed, right? So we have done all of this. Then we need to enable we need to add under the EVPN. Remember, if you do show run EVPN, currently we don't have redistribute host route, right? So the type 2 routes need to be redistributed into type 5, and we have talked about this in the previous videos, but this is basically needed to get those /32 routes in your routing table, right? So again, I'll not dig deeper into this right now because we've talked about this in the past. You can go back and check the VXLAN videos with Aruba, right? All we gotta do is you gotta go inside EVPN and go inside the VLAN, then redistribute host route. Okay, go inside VLAN 102, redistribute host route. So by doing that, you basically will end up getting your /32 routes in your routing tables, right, for the VRF. Cool. And the last part is the virtual MAC, right? We also need a virtual MAC, because this is the MAC address which will be used as the destination MAC, for the inner packet when the VXLAN tunnel is or the L3 VNI is used, right? When you do L3 VNI, the inside frame, right? The source MAC address is already known, but we don't know the destination MAC address, right? So this is a unique MAC address per VTEP which needs to be configured. At this particular, since this is leaf 1, I'm going to use :00, maybe one more 00 and maybe 33, right? So that's what I'm going to stick to. All right, now let's just verify what and all we did. Clear screen, show run, right? Just to verify. So let's start from the bottom. Maybe under BGP we enabled type 5 routes, which is needed using that configuration. Under VXLAN we enabled L3 VNI, we enabled routing and added it to the VRF. Under we created the 2 SVIs over here because we need the Anycast gateways, right? Distributed Anycast gateways for VTEP. So as you see here, you've got these two guys. You have used Anycast gateway feature to enable that. We have used active gateway feature to kind of give you the Anycast gateway experience, right, for your VTEPs. Then we also enabled under EVPN, we did the redistribute host route, which is needed for the type 2 being redistributed into type 5, and it will then show up in your routing tables, right, as the /32 route. So that is needed, basically prevents suboptimal routing, right? That is the need for this. And we also enabled the virtual MAC, which is the inner this is also going to be shared using the BGP updates, right? So that a VTEP knows what is the destination MAC address it has to use if it has to use the L3 VNI and send the frame all the way across to the here VTEP. All right, so that's all the configuration on the leaf. Give me a couple of minutes. Let me just go and do the same thing on the leaf 2 and 3, and then we will test this. All right, so the configuration has been done on the leaf 2 and leaf 3. Let me clear the screen just to kind of show it. This is what we have, right? So under BGP, we have enabled type 5 for the leaf 2. We have enabled the L3 VNI over here. As you see, we've got VLAN 101, 102, right? The SVIs, and you can see the Anycast gateway. The Anycast gateway IP address is same as we used in the leaf 1. The MAC address is also same, which is as per design. What else? So we all under the EVPN, we have enabled redistribute host route. The virtual MAC has been enabled, right? The same thing has been done for leaf 3 as well. So if I quickly show you, right? Clear screen, show run, and there you go, right? So you have the VRF for type 5. This is the VXLAN L3 VNI is enabled. You've got the SVIs, and on the top you have the virtual MAC and the EVPN configuration. So that's basically the configs, right? Now if you want to quickly look at the BGP table, show BGP L2 EVPN, right? Probably let's quickly look at this. You should be able to see some of the endpoints. For example, this is the L2 VNI, right? This is 3.10. You can see this is the gateway. This is the gateway IP. You can see 101.30. So it looks like the Leaf 3 has already learned this particular one of the server, right, in 101 VLAN, and it is showing up here as type 2 route. And maybe I think that's mainly it. So now let's probably generate some traffic, and then you also have corresponding, so that was all L2 VNIs. Below you can see the L3 VNIs as well, right? This is the L3 VNI, this is the route distinguisher. So this shows that this is basically a route coming in from the Leaf 1, because it is 101.3. This is coming from Leaf 2, and then this guy is coming from Leaf 3, right? Because route 7. So that's how you can identify, using the route distinguisher, you can identify from where is that route coming from, right? And you can see the IPs here, right? You can see 101.30 has been learned because maybe it sent some traffic and that's how it learned, right? If I probably trigger some traffic now, let's probably go to this client, right? Earlier, remember, if I scroll a little bit top, remember when we tried to do a ping to 10.0.102.10, right? From this particular host, from VLAN 101, when we tried to talk to VLAN 102, or when we from one L2 VNI, when we tried to talk to other L2 VNI, it did not work, right? Why it did not work? Because we had shut down the routers. We had shut down our external routers. Now let's try the same thing and see if it is going to work, right? So I'm going to copy the same thing. As you see here, it did not work. So I'm going to copy the same thing, come down here, and there we go, it's working, right? And if I probably come down here and look at the table again, you should probably see that for the L2 VNI 10, yeah, there you go, right? So the 101.10 is getting learned, correct? So you can clearly see here, this guy it is coming from Leaf 1, and it is coming here as a type 2 route, right? So similarly, if I scroll down, if I probably, what did I ping just now? I pinged 102.10, right? So ideally what I showed you was 101.10. We should also have 102.10, right? So that is also basically getting learned from, this is the route distinguisher pointed to Leaf 1, right? So you can see this is the route which is getting learned over there as well. Cool. And similarly, you have the L3 VNIs over here. So the redistribution, what we have done, right? The type 2 routes are basically showing up inside inside the L3 VNI as well, because of the host. We have done redistribute host route, right? So you can see these guys are showing up here. .10 is showing up, .30 is showing up, and stuff like that, right? But basically this is what we wanted to prove, right? So we are able to now ping, as you see here, show IP interface brief. This was basically the 101 segment, and we were able to ping this particular IP, which is in the different segment, right? So we are able to ping from 101 to 102, and which basically means that the fabric which we have set up, right, is able to actually do routing, right, without the need of these routers which we have already shut down earlier, right? So that's what I really wanted to kind of talk in this video. In the previous video, we kind of went through setting up a L2 DCI over VXLAN. In this video, we expanded that, and we actually showed that you don't need external routers to do the routing. Rather, you can do the routing within, you can basically do the routing within VXLAN itself using the integrated routing bridging IRB feature, right? And as a result, we were able to kind of route between the two segments which we have here, using VXLAN and not using the external routers, right? Typically, you use the design where you use external routers is predominantly if you want to do some sort of security treatment, maybe you want to put some firewalls and you want to inspect the traffic, then maybe you can go with the option 1 or the option which we looked in the previous video, that is introduce an external device like a router or a firewall. But otherwise, right, if your goal is just to enable L2 overlays and L3 overlays, then VXLAN itself should be able to do that, right? With that, we'll conclude this video. Hope you found it useful. Like I said earlier, go back and check the previous videos in the series, because this is more of a continuation. So you will get all the configurations and all the topologies and all the discussions which we have done in the previous videos will actually really help when you're kind of looking at these later part of the videos. All right, have a good one. Bye.